In this video, we're going to talk about half-lives and more specifically, nuclear half-lives. So a half-life is exactly what it sounds like. Is the amount of time required for one half of the original amount of radioactive sample to undergo decay. So if I start off with maybe 50 grams of my sample, one half-life would take me to 25 grams of sample. There are a lot of different things that we can use to compare the danger of radioactive isotopes. So we can look at the length of exposure, the type of radiation, internal or external exposure. And this is very important because we talked about how alpha particles are not going to do a lot of damage to you, but that is only if it is external exposure. If you ingest alpha particles, then all bets are off. You can undergo a lot of damage. And that's true with any radioactive isotope. Now, the type of damage it can do will also depend on the half-life. And then it will also depend on the dose. There are a lot of times we are exposed to radiation, but as long as it is a dose that our body can handle, then the damage is very, very minimal. All right, let's look at an example of how we can use the half-life or calculate the half-life or use the half-life in calculations. So, forensic scientists are investigating a suspicious package containing phosphorus 32, which has a half-life of 14.3 days. The initial mass of the package was measured to be 14.3 grams. How much time has gone by if the package now has a mass of 3.6 grams? So when I do this problem, I can start off with my initial amount, and after one half-life, I can see how much material I will have left. So I'll take 14.3 and divide it by 2. That gives me 7.15. This problem is asking about 3.6, so that is not equal to our 7.15 grams. So after a second half-life, I can take my 7.15 and divide it by 2 again, and I get 3.575. Now, this is close to the 3.6 grams, so that tells me that two half-lives have gone by. To do this math, I can just do a unit conversion and I can use my half-life. So if two half-lives have gone by and there are 14.3 days in one half-life, notice my half-life units cancel. I'm left with units of days, which is good. And this will give me, we can take our 14.3 and multiply by 2 to get 28.6 days. This is important. Half-life should have units of time. It's very important that we know how to do these different half-life calculations because radioactivity and radioactive isotopes are used a lot in nuclear medicine. Here are a number of radioactive isotopes and their half-lives. And then you can see what they are used for. A lot of cancer medications and cancer research takes advantage of nuclear medicine. Cobalt in vitamin B12 is used to diagnose absorption of the vitamins. So we have a cobalt atom right here, and we can replace that cobalt with a radioactive isotope. And this can be tracked throughout your body. So we can tell if your body is absorbing the B12 or if it's just going straight through your body. The positron emission tomography, tomo- tomography, which is a PET scan, utilizes radioactive isotopes to get an image, and the image can provide you with the function of the brain. On top, we have normal function of the brain. These two down here are cocaine abusers, and you can see the function in the brain is very, very different. In forensic chemistry, we can use carbon 14. Now, carbon 14 is a radioactive isotope of carbon, and this can be a very useful radioactive isotope because carbon is literally in almost everything that comes from the earth, and it is created in the atmosphere. Now, carbon 14 is continually taken up by plants and animals while they live. So you can do all kinds of carbon dating to determine how long something has been dead, because after death, the carbon 14 in an organism is going to start to decay. So the age of a sample can be determined by how much carbon 14 is left in the sample compared to the original concentration. The half-life for carbon 14 is 5,730 years. Let's look at an example of how this can be used. A burned fragment of wood is found at a crime scene. To determine the age, forensic scientists use carbon 14 dating. The fragment contains only 12.5% of the original carbon 14 concentration compared to a living sample. So we can calculate the approximate time since the tree was cut down, because that's when it would have died. The first thing I need to do is calculate how many half-lives have gone by. So if I originally start off with 100%, I need to see how many half-lives go by in order to get down to 12.5. After one half-life, I'll be at 50%. Two half-lives will take me to 25%. And finally, three half-lives will take me to 12.5%. So this tells me that three half-lives have gone by. The next thing we can do is use the half-life to calculate the approximate time. On the previous slide, we saw that the half-life of carbon 14 is 5,730 years. So I can use that half-life to figure out the age of this wood, if you will. The half-life is 700 or 5,730, and that is years in one half-life. And I know that three half-lives have gone by. So I can plug this into my calculator. 5,730 times 3 is equal to 17,190 years. Man, that is one old piece of wood.